Hello everyone, let's take a look at LeetCode 973. It's an interesting problem since there are more than one solutions. And it's called K closest point to origin. And we know it's a very typical sorting problems. There are n points and we need to return the K closest points. Okay. So if we return the K points, the answer we return can be in any order as long as there's a K closest. So the first solution is very trivial, sort. We have n points, so we can sort them first and return the first K points. For time complexity, since we're using sort, so it's n log n. We can improve it by using priority queue. We can maintain a maximum heap of size K. Since we have n element, so the time complexity is n log K, which is better than n log n. Okay, for third solution, so expectation running time is O(n), or we can say the on average is O(n), but in worst cases it can be O(n) square. But we know on average is much better. So let's talk about what quick select is. It's very similar to quick sort. For example, for this input, we need to find the first element. How do we find the first element? First, we can pick a pivot. For example, we can pick the first element or we can pick the last element, never mind. Then we just do partition. So all the elements that are smaller than the pivot will be on the left. All the elements greater or larger than the pivot will be on the right. We know we need to find the first smallest element. Since for this pivot, there are 5 elements smaller than pivot, so we know the fourth element will be on the left part. So the red part, like in gray color, we don't care about them. So the subproblem is find the fourth smallest element in this green array. Okay, now we run our algorithm again. We do the partition. Then we know so one element before the pivot and one element in the pivot. So the first element will be on the right part. So the subproblem becomes we need to find the second element in this green subarray. Okay, we pick the pivot again, then do the partition. Then we know this subproblem becomes we need to find the first element in this green subarray. Then we pick a pivot, we do the partition. And we know there one element before the pivot, and we need to find the first element. So the answer is in the left part. So the subproblem becomes find the first element in this green subarray. And so we can say the condition meets, we find the answer, then we can stop. Okay, you may find after the quick select, all the elements before our answer are smaller than for all the elements greater than for in the right parts, and they are partially sorted, which means the whole array is not sorted, they're partially sorted. It just has one property. All the elements before the answer are smaller than 4. All the elements on the right are greater than 4. So we know if we want to return the closest K points and they are just in the left part, we just return the left K points. So that's an idea of the quick select. Of course, in some cases, it's important to pick the pivot. In each iteration, we, in the ideal world, we want to pick a median number so we can partition the array into 2 parts, and every time we can drop half of the elements. But in some cases, assuming that the array is already sorted 1, 2, 3, 4, then we pick the pivot, which is very bad. So it can be degraded to O(n) square. Since each iteration we may just drop one element. So sometimes we may want to use an algorithm called randomized select. This algorithm is talked about in Introduction to Algorithm, this textbook, also called CLRS. It's in chapter 9, section 2. it introduced the randomized select, and I also implement it here. So you can search my repo here, and then this partition is, so it just use the random partition. We just pick a random pivot, so which can maybe like for the, if the array is already sorted, we can improve it. Okay, so I just provide two implementation here. The first one is you can ignore the nth element if we are using sort, and uncomment the sort. We just provide the compare function and pass it to the sort function, then returns first k elements. Like for the quick select in C++, it has an internal function called nth element. It's just doing which we talked about previously. So we pass this two pointer or two iterator begin and end. We pass another iterator points dot begin plus k, which means it will place the kth element at this position, and all the elements before this position are like smaller elements. All the elements after the kth position are larger elements. Then we can just call this nth element and return the first k points. Okay, that's it. Thanks. See you next time.